We are continuing with design of general purpose industrial helical gear reduction unit, and this is part 3 and week 5, and this is lecture number 22. And in this lecture I will show how the output shaft drawing can be developed, and also the second stage, that is the last stage, output stage gear also. Now, in this lecture I shall cover again we will first show the design problem, gear data and dimensions, and then first layout, this we will recapitulate, and then input, pinion, integral with shaft, intermediate shaft layout, and then output shaft material and size estimation, then development of gear side output shaft, choice of bearing, placement of key output gear and spacer, gear end bearing, locking arrangement, use of circlip, and that again this is the problem. Just to mention that it is of around 24.5 reduction ratio, second stage around 5.2, and first stage the rest of the part 4 point something in the first stage. And in this stage the last stage we have module is 4 millimeter, and the gear dimensions already we have discussed many times. Then first we will I will show the layout what we have already developed earlier, that in that we placed only the center distances and the gears and pinions. Okay. And this is the intermediate shaft which we have already developed, and then here I have shown that the developed intermediate shaft. Why we have developed the intermediate shaft first? Because that give the idea of both side, input side and output side. So, first we have developed the intermediate shaft with bearings, gears, everything, locking arrangement, everything we have shown here. We have made as much as detail possible of the shaft. We have also shown that possible arrangement of locking with the gearbox housing. Then we have the same way I have shown also the input shaft arrangement with the bearing locking arrangement. Okay. Now, we shall so this means that if you look into this gearbox, this is intermediate shaft and the input shaft is already developed and shown, and the center distance 150 to 200, that we what we have done. This is the sub assembly of intermediate shaft that we have done early, and then the sub assembly of input shaft right hand side. Now, we shall first discuss that what might be the size of the output shaft. First thing, that the output gear is large size, and it may not be required why may not be? It is not required to make this gear integral with the shaft, which was required for the input shaft and the intermediate shaft. And in those two shafts, if this pinion are made separate, that is separate from the shafts, then shaft side will be so less that it may not be able to withstand with the bending moment there or even torque there. So, that is why it is essential we have to make these two pinions, input and intermediate pinions, integral or other words first stage pinion and second stage pinion integral with the respective shaft. This means that there the shaft material is the pinion materials and which is having high strength. But in this case, as the shaft is being made of other material, as well as if there is a space for making the shaft large, so we can go for some other material. And what might be the probable size of the shaft? Then we will think of that in the intermediate shaft pinion we have taken 45 millimeter. So, in that case, in this case output shaft, definitely the bearing size will be higher than that. So, first possibility is that at the bearing end, at the step for bearings, we can keep the diameter is around 50. Why around 50? It is 50. That means, we can consider the 6310 bearing. Then with that assumptions and considering that bearing material will be medium carbon steels which are widely used for that purpose, and for which say EN 8, C 40 or C 45 having the ultimate strength of 570 megapascals and yield strength of 280 megapascals, we can assume that shaft diameter will be on the bearing will be 50 millimeter. And the bearing number is 6310 and the output end after putting the bearing in the output side of the shaft, again we will require one step for sealing and then the next step for coupling. That coupling step or which is output end we can be taken 40 millimeter. So, we will check there is also pure torque, assuming that we will check whether what will be the shear stress there. Now, in this case we have multiplied the nominal input torque by twice, because it is there is a heavy shocking load. So, with that what we find, the shear stress is coming 116 megapascals and the material is medium carbon steel, and this is in higher side. However, if necessary shaft size may be altered also, and but still what we can consider that with the nominal torque the stresses will be half of that, that means around 58 megapascals, and the yield strength is 280 megapascals, and probably there will be no harm if we use the same diameter and the same material for the output shaft. Now, with this first preliminary selection of the shaft material and what might be the size, then we start developing the output shaft. Now, this center distance from the intermediate shaft, it is 200 millimeter, and we have again introduced the center line, and then we are developing the output gear end side. There we find that if we keep the bearing diameter 50, then to reduce the overall size of the shaft, probably we can go for the shaft diameter about 55 for the gear, and that means where the gear will sit, and then for bearing we are keeping 50 and the shaft diameter after the gear, that means here after the gear. So, this is for the gear, this portion we have kept for gear. Okay. Next, this portion which will be raised, maybe we will take 55 plus say 12 to 13. Okay. So, it might be 63 here, that means this portion can be made 563. So, we can have a stock of 65 millimeter diameter, and from that stock we can make this shaft. Okay. With this idea we proceed. So, now we have again we have provided two undercuts, one for setting the bearing, another for setting the gear. Now, here I would like to mention these undercuts at the when the step up of the shaft where the gear will sit, that means here we may not provide the undercut, it can be simply a step up, but in that case we have to be ensured with the gear that there should have a good amount of chamfer. But if you provide the undercut, then their chamfer may be very small and we will have more support, shoulder support for the gear. Anyway, we will again, I would like to say that we will see later when we will make the detailed drawing. Now, we put the keyway. Okay. So, we have initially developed the shaft diameter here for sitting the gear, and also we have considered where the bearing can sit. Then we consider that the key for locking the gear with the shaft. So, this is again taken from a standard key is taken from the catalog, and then we have drawn it here, and then we have put the gear there, key and gear. Okay. So, this is output second stage gear. Now, from the gear end towards the bearing side, the step is very small, therefore, we need to provide a spacer that we will look into this, but here again details of this portion is shown here. We have provided undercut here, this undercut is here, and another undercut we have provided, this is here. Okay. These two undercuts are there, and here simply a step down. Here we should keep in mind that the width of the gear and this length will be less than the width of the gear which is shown here. Otherwise, when we will put the sleeve, that will not touch the gear end. So, that care must be taken while we are considering this design. So, this is the undercut, here it is shown, that is the undercut what I have already discussed, and this is the QA. Now, the choice of bearing. Now, we will think of the bearing. Now, as the intermediate shaft bearing, what we have selected 6309 of 45 millimeter diameter, so that it will have almost double the expected life. So, we can perhaps go for the bearing 6310, that is the 50 dia bearing for the output shaft. Otherwise, we have to go for one size higher, but this again we may need to redesign after verifying the bearing life and the shaft design. So, at the present moment we shall proceed with shaft diameter is 50, and here the dynamic load capacity will be around 4500 Newton, and we will check later as I have mentioned. So, we will, however, we will proceed with that bearing. So, first of all we put a sleeve here, and then sleeve, it is also called spacer. Now, this spacer is used to transmit the axial load from the inner race of the bearing to the gear and vice versa. Okay. So, now we will put, now we will consider the bearing, and we will put the bearing. You see, this is bearing is touching here the sleeve, and sleeve is touching the gear surface. So, any load is coming on this bearing, that will be transmitted, and finally, if we lock this bearing with a circlip, then this side the bearing is fully locked in both ways, it cannot move any way, and if we can now lock this bearing with the housing, so that end can take the load, otherwise we will keep that free, we will lock the other side bearing. Okay. Now, in next phase, this is the circlip, and this is the detail of this port set what we have developed now. Circlip, the bearing is 6310, and we have so far we have developed up to the end of this shaft bearing here, this side. We will now develop in the other side of the bearing, which we shall continue next. But before that, I just want to give you some hints that this side we have considered that shaft, it may come like this, okay, and other side we will put the bearing here. So, we will develop in that way, and then we shall consider for the bearing. Now, in choosing this output shaft, the one question will arise, whether why we are putting the input and output side in the reverse directions. This is one reason is that the size of the machine and the size of the prime mover may be such that we cannot put the input and output in one side. So, it will be in the other side. The next question will arise that is it possible that we can reverse this? This means that can we put the input end this side and this side we can put it off. Similarly, whether we can put the output in this side, the answer is yes, we can definitely put it. We can put the other side also, that instead of making at the bottom we can put the output side, the top end. Anyway, we shall continue this in the next lecture.